today's lesson is Unit 3, Lesson 3. Our topic today is function families. And period 4. So we'll talk about, in general, a function family. A family of functions, or function family, is a set of functions whose equations and graphs have similar form and shape. So, for example, we have these first 3 graphs, similar form and shape. They all look like what kind of a graph? They all look like starts with an L. Linear, good. Linear, they're all lines. We'll call this the linear family. The linear functions, actually. If we wanted to stretch it out, we could say the linear family of functions. And then number 2, we talked about these yesterday. They are all in the shape of a V in different places and in different sizes. And a V is what type of function? Absolute value, good. So this is sometimes they're involved in piecewise functions. Absolute value is the name of the family. Now, at some point or another, every family stems from a set of parents. So, the same holds true to function families. A parent function is the simplest function of the family. For example, the linear function f of x equals x. The most basic form of a line. Goes through the origin as the y-intercept, has a slope of 1. Absolute value function, the most basic form of the absolute value function, like we talked about in our notes from yesterday, is just f of x equals the absolute value of x. And similar to the linear parent function, it goes through the x-axis. It goes through the origin, I should say. The y-intercept is the origin. And the slope to the right of the y-axis is 1. Just kind of like this linear parent function. Very, very similar. But instead of continuing down into the 3rd quadrant, it bounces up into the 2nd quadrant here. So it has a slope here of -1. So 2 examples of parent functions. We'll take a look at a whole variety of additional parent functions later on in this unit. For today, we're going to focus mainly on the absolute value function and transformations. So transformations, can you read that for us, please, Piper? A transformation changes
the position or size of a figure. Transformations can be applied to parent functions.
Great, thank you. It all starts with the parent function. So here is the part of the lesson where you turn to Desmos. It says, let's use the absolute value function as an example. Using your calculator, graph the following functions, then compare to the parent function. Give a brief description. So we're going to use words to describe how the f of x equals absolute value of x plus 2 varies from, start by graphing in Desmos. F of x equals the absolute value of x. So I'm going to rely on you to graph in Desmos this function here, f of x equals the absolute value of x plus 2. On the first line, I want you to keep this function, f of x equals the absolute value of x. And then the second line will change in Desmos, depending on what question we're doing. So you can see on the screen here, what words would you use to describe the movement from the parent function, that's purple, to the black function, that is example number 3? I heard it.
Transformation to
2 units left. Excellent. We're going to use the word shift because they're all transformation. Shift left 2. This is how I'm going to say that in caveman language. Shift left 2.
I love chapter 4 in geometry, the transformations and reflections. I love it.
You're going to love this one. That's awesome. Next one, go ahead and type in. In fact, you can just swap out the plus sign for a minus sign in Desmos. And now what kind of transformation do we have? We have a shift where? 2 units to the right. Good. Yeah, this should be familiar from geometry. That's going to be shift right 2. And then go back in. Now notice the plus 2 is outside of the absolute value symbols. And what do we have here? A translation. We have a shift
Up to.
up 2. That's right. Shift up 2. And then we have the f of x equals absolute value of x minus 2. And what type of translation?
Shift down to.
Shift down 2. Good. Now I move to number 7. It's a little bit different. Number 7 has a 2 in front of the absolute value symbols. This is one of those detail-oriented lessons, as many math lessons are.
It's shrunk.
It's closed more. It's shrunk. Okay, we're going to use the word stretch. How's stretching?
Stretched.
Stretched.
It's stretched by 2.
Yeah, great. Did I put that in the right spot? I did that. The 2 goes in front.
Yeah, I was.
So, we'll call this a vertical stretch by 2. And then go ahead and type in the next one. Just change the 2 to a 1/2. Widened, yeah, I like that word. The math word we'll use for that is a compression. So that is a vertical compression by 1/2, is how we'll say that. And lastly, number 9. If we type in the negative sign in front of the absolute value of x, okay.
Expiration of the or reflection.
Reflection, that's the right word, reflection, like you see yourself in the mirror, it's a reflection. So this produces a reflection across the x-axis. This minus sign here creates a reflection across the x-axis. You can kind of see my color scheme here. We've got 3 different types of transformations. The first type is demonstrated by these first 4 examples. These are all examples of a slide or shift. The mathy way to say that is I heard it. Translation. Moving left or right or up or down, those are all types of translations.
I hated graphing those.
The stretch or compression is like going to the eye doctor when they put the drops in your eyes. Dilation. A dilation stretches or compresses a function.
Reflection.
And finally, the reflection. We actually used that word already. Reflection flips a function. I think now's a good time to take a pause. We'll come back